Test 9 review, looking at Module 9 with rational functions. So question 1 says simplify the expression. So treat this like I'm taking two fractions and I'm multiplying them. And when you multiply fractions, you're going to multiply numerator times numerator, denominator times denominator, and then you simplify by dividing out common factors in the numerator and the denominator. So first off, I'm going to take 3 times 12, which gives me 36. X times x cubed, or squared, is x cubed. And then y, b times y. And the denominator, I have 8 times 9, which is 72. I have an x. And then I have y times y cubed, which is y to the 4th. And then when I simplify, I can divide a 36 in the numerator and get 1. 36 in the denominator, I get 2. So I have a 2 in the denominator. When I divide like bases, I subtract the exponents. So x cubed divided by x would be x squared. That would stay at the top as an x squared, because if I take one x away on the bottom, I take one away on top, and there's my x squared on the top. And my y's, if I take one y away on the top, take one away on the bottom, and I'm left with y cubed in the denominator. Question 2. Here I'm just dividing fractions, and when we divide fractions, we're really multiplying by the reciprocal. So the first thing I'm going to do here, because I have a trinomial in the numerators, I'm going to factor those. So if I factor them, I'm going to have an x plus 3 times an x plus 2. So that's my x squared plus 5x plus 6. So I had to figure out what do I multiply to get 6, but add them together gives me 5, which will be 3 and 2. The denominator is going to stay the same as x plus 1. And when I divide fractions, I'm really multiplying by the reciprocal. So the x plus 2 is on top. And in the denominator, I have to think, what do I multiply to get 3, but add them together gives me 4. And that would be x plus 3 and x plus 1. Now I look at common factors in the numerator and denominator. I have an x plus 3 here, divides out with this x plus 3. Nothing else is in common, so my final answer would be x plus 2. And since I have 2 of them, I can just rewrite it as x plus 2 squared. And the denominator, I have x plus 1. And since I have 2 of those, I can put that as x plus 1 squared. Question 3. Here I'm just subtracting fractions. And when I subtract fractions, I need common denominators. So a common denominator of 9y and 6z would be 18yz. And it's 18 because the least common multiple of 9 and 6 is 18. And then I have to use each variable at least once. So there's 2 variables, y and z. So I need to have them in my denominator. Now the next step is just to multiply the numerator and the denominator by a factor that's going to rename the current fractions, but with the new denominator. So I need to multiply 9 times 2 to get 18, and I'm missing a z, so I'm going to multiply that by a z. So I'm going to multiply the numerator and the denominator by 2z. So 2z times 2x is 4xz. And the other side, I'm multiplying that by 3y, because 6 times 3 is 18. I have the z, I need the y. So I'm going to multiply the numerator by 3y. So now it's a negative 7y times 3y, which is a negative 21y squared. Now if I look at all the factors in my numerator and denominator, 4, 21, and 18 have nothing in common besides 1, so I can't divide anything else out. There's no variables that's the same in all 3 parts. 2 of them have y's, but the third one doesn't. 2 of them has z's, but the other one doesn't. only one of them has an x, so that would have to stay as my final answer. Question 4, we have two fractions here. We're going to subtract them, but in order to subtract it, we need common denominators. What's going to make it easier if we factor the denominators to see what could be the same in both to help us determine what our common denominator would be. So I'm going to rewrite this first one. So I got to think, what do I multiply to get 15, negative 15, but add them together gives me a positive 2. That would be an x plus 5 times an x minus 3. And over here, I can multiply or factor out a 5, and that would give me an x minus 3. So in my answer, the common denominator, I use each one of these factors once. So I have 5 as a factor. They both have an x minus 3. So I'm going to put that down. And then I have this x plus 5, which I also need to put down. X plus 5. So that would be my common denominator. So now I don't need these anymore because I rewrote them. So now I need to look at the first fraction, which has the x plus 5 and the x minus 3 in the denominator. I'm missing the 5. So I need to multiply this by 5 over 5 to rewrite my fraction. And then I'm going to distribute the 5, which gives me 10x plus 5. And on this side, I'm missing the x plus 5. So I'm going to multiply that by x plus 5 in the numerator and the denominator. But I'm going to distribute a negative 7 because I'm subtracting all of that in the second fraction. So that would be a minus 7x and a minus 35. So my final answer would be 5 times x minus 3 times x plus 5 in the denominator. And the numerator, I have 10x minus 7x, which is 3x. And 5 minus 35 is a minus 30. And I have nothing else in common with the numerator and denominator, so that would be my final answer. Question 5. Here I have complex fractions. So really I have a fraction in the numerator, I have a fraction in the denominator, and I'm dividing all of those. So one quick way of doing this would be to multiply all 4 parts by the common denominator of all 4 denominators. And just to make this a little bit clearer, this is 2 over 1, and this is 2xy over 1. So my denominators are xy, 1, 1, and y. So the common factor, or common denominator of all 4 of them would be xy. So if I multiply everything by xy, I will now get rid of all the denominators in the problem. So this first one, if I divide xy out here, divide that with that, I'm just left with an x. Here, I need to multiply the numerator and denominator times xy, which will give me a minus 2xy. Now in the denominator here, I have a 2xy divided by 1 times xy, which will give me 2x squared y squared. And on this other one, I have a y in the numerator and y in the denominator. They divide out, and I'm having minus a 3x. Now if I look at what I have in common, all 4 parts in the numerator and the denominator have an x. So if I factor out an x in the numerator, I'm left with 1 minus 2y. And the denominator, if I factor out an x, I'm left with 2x y squared minus 3. And the x's divide out, and I'm left with my final answer of 1 minus 2y all over 2x y squared minus 3. Now I'm just showing you one way you could solve it. The other way you could solve it is by getting common denominators in the numerator, getting common denominators in the denominator, and then multiplying the numerator, or dividing the numerator and the denominator to get your final answer. Question 6, write the function g of x. So for this one, I'm going to put in the new asymptote lines in here, because that's going to help us determine where did the graph move from the blue, which is the parent function, to the purple, which is the g of x, or the transformed one. So I know the vertical asymptote line is right here, which is at -1. And the horizontal asymptote is straight across here, which is at -2. Now, the reason why I was able to determine those asymptote lines there is because the graphs always approach the asymptote lines. And as the x's increase, I can see on the right-hand side that this asymptote, or this graph, approaches the asymptote line of -2. And the same thing on the other side, when x decreases, it approaches the asymptote line at -2 as well. So now, the main function, or the reciprocal function here, would be g of x equaling a over x minus h plus k, where h and k are my asymptote lines. So I'm going to plug those numbers in, and then I'm going to choose a line or point that I know that's on the purple line, the purple graph, as my coordinates to find my a. So I know my h is my horizontal, so it moved 1 to the left. That means it's at -1. So if I have x minus a -1, that really means I have a +1. So I'm going to put a +1 here. I'm still going to be trying to find my a. My k is my vertical asymptote, or my, actually no, my h is my vertical asymptote. My h is my vertical, so this is at -1. My k is my horizontal asymptote. The k went down 2, so I'm going to have a -2 here. Now I need to choose an xy coordinate that's on the line. I'm going to choose this one right here. There's multiple choices I can have, but I'm going to choose this one because the coordinates of that one is 0, -1. So if I put a -1 for my y and a 0 in for my x, I can now solve this. To solve for a, I need to get the a over 1 by itself by adding 2 to both sides. So now I have -1 plus 2 is 1 equals a over 1. And a over 1 is just a equaling 1. So my final answer, my equation, is going to be g of x equals my a of 1 all over x plus 1, and then my k, let me just get rid of that part here, my k is going to be a -2. And this would be my function. Question 7. Here we need to graph this reciprocal function, so we're really doing the opposite of what we just did. The last one we had to come up with the equation from the graph. Here we have the equation, we're going to now graph that. So in order to do this, we're going to put our asymptote lines in here first. So I'm going to have my vertical asymptote, which if I look at x plus 3 in the denominator, if I make that equal to 0, x is going to be -3. That means the vertical asymptote line went 3 to the right, or 3 to the left. So I'm going to draw my vertical asymptote line right here. And then my horizontal one is my k, which is a -4, so it went down 4. So those are my asymptote lines. Now I'm just going to use points on each side of my vertical asymptote to plot some points so I can draw my graph here. So if I go to the right of the vertical asymptote line, I have -2. If I put -2 in for x, -2 plus 3 is 1. 2 divided by 1 is 2. 2 minus 4 is -2. So I have a point at -2, -2. Now if I put -1 in there, -1 plus 3 is 2. 2 divided by 2 is 1. 1 minus 4 is -3. So I have a point at 1, -3. So I can see that my line, as it approaches the vertical asymptote, comes down and hits this green point. It's this green point and then follows along this horizontal asymptote line. Now the other side, let's choose 2 points on the left-hand side of the vertical asymptote. So if I put -4 in, -4 plus 3 is -1. 2 divided by -1 is -2. -2 minus 4 is -6. So I have a point right here. And if I put a -5 in, -5 plus 3 is -2. 2 divided by -2 is -1. -1 minus 4 is -5. So I have -5, -5. Then I can draw my graph. It's going to come down like this. And there's our graph of that reciprocal function. Question 8. Here we have a rational function here. So the first thing we're going to do is we're going to determine our vertical asymptotes. So the vertical asymptote is what's going to make the denominator equal to 0. And if I do x plus 3 equals 0, x would have to be -3. So I'm going to put a point, or a vertical asymptote, at -3. So here's my vertical asymptote line. Now the horizontal asymptotes. One thing you have to remember is if I take the degree of the numerator divided by the degree of the polynomial in the denominator, if the numerator has a bigger degree than the denominator, there is no horizontal asymptote. But if it's just if it's just 1 degree bigger in the numerator than it is in the denominator, then I know I have a horizontal, or I have a oblique or a slant asymptote line. And since this is 2 minus 1, I have a degree of 1 degree bigger. I need to do long division to find out what the line is for the slant or the oblique asymptote line would be. So to do that, I'm going to take my denominator of x plus 3 and I'm going to divide it by, and here I'm going to do synthetic division with this one, since that will be a little bit easier and less spaced to do that. So I'm going to have a -3 here, and I'm just putting the coefficients of my numerator, which would be 1, 2, and 1. And I bring the first term down, and I multiply on the diagonal, so -3 times 1 is -3. Add straight down, and I get a -1. -3 times -1 is a +3, and I get a remainder of 4. So now, since I'm 1 degree below, this will be my x. So x squared goes down to be an x. So I have an x minus 1. So my vertical or my horizontal asymptote is actually going to be crossing the y-axis at -1, and it's got a positive slope, so up 1 over 1. So now I can put my asymptote line in here. And then all I need to do now is just choose points on the numerator and the denominator, or just choose points, 2 points on the right hand of the vertical asymptote and 2 on the left hand. So if I put in a -2 in for x, -2 squared is 4. 2 times -2 is a -4, so 4 minus 4 is 0. 0 plus 1 is 1. So I have a point at -2, +1. If I put a -1 in there, -1 squared is 1. 2 times -1 is -2. So 1 minus 2 is -1. -1 plus 1 is 0. So I have a point at -1, 0. So that would be right here. Then if I want to put one more point in here, so if I put a 0 in for x, in order to make, actually I forgot to do the denominator parts. So let me erase those points here. So if I put a -2 on top, I get a 1. And if I put a -2 in the bottom, -2 plus 3 is 1. So 1 divided by 1 is 1. So that means I would have a point at -2, 1. So that point was correct. Now if the -1 in there, -1 squared is 1, minus 2 is -1, -1 plus 1 is 0, and then I have 1, -1 minus 3 is, plus 3 is 2, so 0 divided by 2 is 0, so that point would be right here. And then if I put a 0 in for x, I would get a 1 over 3, which is 1/3, which would be here. So now if I were to draw my graph, it would come down like this. So that's the first half. Now the second half, I need to choose a couple points on the left-hand side of the vertical asymptote. So if I put a -4 in for x, -4 squared is 16. 16 minus 8 is 8. 8 plus 1 is 9. And then if I put a -4 down here, -4 plus 3 is -1. So I got 9 divided by -1, which is -9. So I have -4, -9, which would be down here. If I put a -5 in there, -5 squared is 25. 25 minus 10 is -15. -15 plus 1 is -14. And at the bottom, I have -5 plus 3, which gives us -2. So I have -14, or 14, or no, it would be 16 on top. 16 divided by -2, which will give us a -8, which this will give us a point right here. And then if I were to put a -6 in there, -6 squared would give us 36. 36 minus 12 is 24. 24 plus 1 is 25. 6 minus, or -6 plus 3 is -3. Then I would have 25 divided by -3. If I already have enough to draw it, I know this is going to come along like this. But another way of doing this one, if you want to verify, is just get your calculator here. Go to the y equals. If I just type in the equation, so the numerator I have x squared plus 2x plus 1, and parentheses divided by parentheses x plus 3. And if I were to hit graph, you can see the first part, you can see my vertical asymptotes. But if I wanted to check my points here, the table values, I know it's at -4, so I'm going to go all the way up so I can see -4. Actually, not -4, -3. You can see we have our points at -2, 1, -1, 0, 0, 1/3. If I were to do another one, 1 and 1, which that would be like right here. There you can see my -5, -8, -4, -9. If I were to do another one, -6 and -8.3 repeating. Remember we had 25 divided by 3. 25 divided by 3 would be -8.3 repeating. So that is another way, a quicker way of coming up with your points without doing all the math. You can use your graphing calculator for that one. Question 9. Here's a variation problem. If y varies inversely as x and x equals -5 when y equals -1.1, find y when x equals 2. So there's two formulas that you can use. It doesn't matter which one you're going to use because you're still going to have to cross multiply. I tend to use the second one here. So this would be my x1, y1. Here's my 2. Here's my x2. So when so I have -5 times -1.1 has to equal 2 times y subscript 2. So this is going to give me 5.5 equals 2y subscript 2. To get y by itself, I divide by 2. And on my calculator, I can easily just do 5.5 divided by 2. I get an answer of 2.75. So y subscript 2 would be 2.75. Question 10. Use the formula a1 c1 divided by b1 equals a2 c2 divided by b2. So suppose a varies directly as b and a varies inversely as c. Find b when a is 6 and c is 28 if b equals 7 and when a is -49 and c is 3. So when it says it varies directly, that means I'm going to be multiplying the constant by b. But in order to get the constant by itself, I'm going to divide by b. So that's why I have a subscript 1 divided by b subscript 1. So this is going to be my 1. Actually, here, we need to find b subscript 1 when a subscript 1 is 6 and c subscript 1 is 28. So I'm going to have 6 times 28 divided by b subscript 1, which I don't know. This is going to equal, a is -49 times my c, which is 3. We're going to divide all that by 7. So the quick way of doing this one after you have it all set up is just put it into your calculator. So I'm going to have 6 times 28 equals 168. So I'm going to write 168 all over b subscript 1. This is going to equal, and on this side I'm going to have -49 times 3 equals a -147 divided by 7. And now from here, all I'm going to do is cross multiply and divide. So I got 168 times 7, and I divide that by a -147. That's going to give us b1 equals -8. And our last two problems, question 11. Here we're going to solve a rational equation here. To do this one, to make the numbers a little bit easier, I'm going to simplify 15/12. So if I divide a 3 here, I get 5. Divide a 3 here, and I get 4. So really, I'm just making it equal to 5/4. And just like what we did earlier in the earlier in the review, I want to get rid of my denominators. To get rid of my denominators, I'm just going to multiply everything by the least common multiple. And the least common multiple is 4 times x minus 7. And why is it 4 times x minus 7? Well, the common multiple of 4 and 2 is 4. And then I have to use the other factor of x minus 7. So I'm going to multiply everything by 4 times x minus 7. And then simplify from there. Okay, so this has x minus 7, this has an x minus 7. So now I'm left with 4 times 3, which is 12, plus, take a 2 out here, divide a 2 here. And now I'm just distributing a 2, because 2 times 1 is 2. That gives me 2x minus 14 equals, here divide out of 4. Now I'm just distributing a 5, which makes this a 5x minus 35. Now you would have still gotten the same answer if you made it 12 times x minus 7. Your numbers are just going to be bigger. Now I just get all my x's to one side and all the other numbers to the other. So this would be negative 2 plus 2x equals 5x minus 35. I'm going to subtract 5x. And then I'm going to add 2. And I'm left with negative 3x equals a negative 33. Divide by negative 3. X is going to equal a positive 11. And our last question says Mexican free-tailed bats have an average flight speed of 25 miles per hour. Suppose it takes one of the bats 5 hours to fly 121.8 miles round trip one night. Assuming that the bat flew at a constant speed, determine the speed of the wind. Use T equals D divided by R plus the W. The W is our wind speed, so really it's all based on rate times time equals distance. So we're going to use the time, the total time. So we're going to take the time for one direction plus the time on the way back, which is going to give us the total time. So the total distance is 121.8, but we're going to cut it into two trips. Trip 1 is 121 divided by 8, which is 60.9. So I'm going to do 60.9 divided by, the rate was 25 with the wind plus the wind. And then we're going to add that to it, the trip back, which was 60.9 miles. And then it's still 25 miles per hour, but it's without the wind, or against the wind, so that's a minus the wind speed. This is going to give us a total time of 5 hours. So now I'm just going to solve for W, but remember I need to get rid of the fractions. So to get rid of the fractions, I'm going to multiply the least common multiple, which in this case is going to be 25 plus W times 25 minus W. So I'm going to do that to all three parts. Now simplify it. I have 25 plus W here, 25W plus there. So now if I distribute, I'm now going to have 25 times 60.9, which is going to give me 1,522.5 plus, or not plus, that would be minus 60.9 W. That I'm going to be adding. Here the 25 minus W divides out with that 25 minus W, and I'm going to distribute, which is going to give me 1 1,522.5, and then I have a plus 60.9 W. So I'm just doing vertically here, and whatever that is, it's going to equal, now I have a difference of 2 squares here, and then I have a 5 there. So I'm going to have 625 minus W squared times 5, which if I do 5 times 625, I now have 3,125 minus 5 W squared. And this side, 1522.5 plus 1522.5 is going to give me 3,045, and then the W's cancel each other off. So now I'm just going to use the rest of it with my calculator. So here I have 3045. I need to get the W squared by itself, so I'm going to subtract 3125 on both sides, and I get negative 80. Divide that by negative 5 to get the W squared by itself, and I'm left with 16. To undo, so now I have 16 equals W squared. Now I gotta think, how do I undo a square? So to undo a square, I find the square root. Now the only time, or the only wind speed that would make sense would be the positive root, which would be a positive 4 miles per hour. So that is our review on rational functions.